Okay, so good afternoon. So let's discuss quickly rectangular plate bending elements. So we have 3 displacements per node, okay, in this plate element. Okay, and we assume a displacement function since we have 3 displacement per joint. So 1, 2, 3, 4. So 3 times 4, we have 12 unknowns. Okay? So which is consistent dito sa ating displacement function. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 unknowns. And this is our displacement function. Since basically we have vertical displacement denoted as W, and then 2 angular rotation on the 2 axes. Okay, but remember in beam, this topic is more like an extension ng Euler-Bernoulli. No? So di ba sa beam, theta is simply dW over dx, di ba? Okay, this the vertical first derivative, no, vertical displacement. So which is this one. So we need to find the first derivative ng ating displacement function. Okay. So we have dw dy. So the variable of y. Okay. So we have alpha 2. Yan. Variable ng y. So this is constant, no? Ito. Okay. Alpha 4 xy. So alpha 4x. Okay. And then 2 alpha 5 y. Okay. Constant. So wala yan. And then alpha 7 x squared y. Okay. Okay. So on and so forth. Okay. So ganun din sa theta y. Ang variable naman is x. So we have this. In matrix form, you can express this w, theta x, and theta y as this. Okay. Now, let's assign the x dimension as a, while the height is b. Okay, then consistent dapat, no? So this is node 1, node 2, node 3, node 4. So for example, kaya nilagyan ko ng column. Yan. So say node 1, okay? Let's use this matrix. So ano yung x coordinate ng node 1? Diba? Basically, this will be, sinulat ko na pala yan dito. Oops, wait. Okay. So node 1 is 0, 0. Node 2 is 0, B. This is B. This is A. Node 3 is A, comma B, while node 4, A, comma 0. Okay. So for node 1, our x is 0, our y is 0, right? So may kita nyo dito, kaya 0 to. Okay? And since 0 to, lahat to ay 0. Okay, for node 2, our x is still 0, but our y is b. So y is b. Okay? And for example, node 4, node 3, this one. Kaya papansin nyo, ang maraming value here is node 3, corresponding to node 3. Meron kasi siyang value ng A and B. Okay? Or in matrix form, again, we can express this whole thing as, diba, this is the displacements vector. Then this is our phi. And this is our unknown constant alpha. So D equals phi alpha. Or alpha is equal to phi inverse times D. Okay? Also, similar to beam, we express the strain curvature as the second derivative, diba? D squared W over dx squared, d squared W over dy squared, and curvature in xy is 2 times d squared W over dx dy. Okay, so we need to find the second derivative of our displacement function. And this is the second derivative of that. Okay? Or in matrix form, curvature x and y, and xy is this one. Okay? So, for example, 2 alpha 3. Okay. So, this is alpha naught, alpha 1, alpha 2, alpha 3. Okay, and then 6 alpha 6x. 4, 5, 6. 6 alpha 6x. Okay? Or in general, this is curvature is equal to V alpha. Since alpha, as we note earlier, is P inverse D. So curvature is equal to V P inverse D. Okay. Now remember, in beam, this is how we express the moment. Moment is equal to EI times D squared D over dx squared. Or basically, this is the curvature. Okay. So in plate, corresponding expression in plate is D, the D matrix. In beam, we only use the elasticity and the curvature, okay, which is this one. Okay, therefore, substituting the curvature from here, this one, substitute natin dito. So we have D times B, P inverse times the displacement vector. Okay, so this is the D matrix, okay, for plate bending. Okay. So sinulat ko siya dito. Now again, in beam, this is how we express the strain energy. 1/2 integral of the curvature transpose m dx. Or basically, this is the strain energy in one-dimensional and force. Because in beam, we deal with moment as the force. No? So similar to beam, extend that to plate. This is the strain energy, 1/2 double integral curvature transpose m dx dy. Because we are dealing only, we consider only the plate bending as two-dimensional. So dx dy and double integral. Then substitute the formula for curvature, which is this, b times p inverse d, b times p inverse d. Okay, and then what's the formula for so this is b times phi inverse d, then transpose formula for moment here is d times curvature, right? Okay, then again, as a property of matrix, when you transpose this inside, mag-interchange yung position nila. So we will have d transpose, itong nasa dulo na punta sa unahan, yan, phi inverse transpose, and then itong nasa unahan na punta sa dulo, so b transpose. And then d and curvature dx dy. I-extract natin yung phi inverse. This one, napunta dito. Then pagsamasamahin natin yung b transpose db. B transpose db. Because curvature is again b times phi inverse d. Okay. Sorry. Remember, so after this, we will get the partial derivatives, right? With respect to the d. So mawawala itong d transpose. Okay? So mawawala to. That's why in-extract si phi inverse here, tapos naiwan si b transpose db, then the other phi inverse, ito is napunta dito. Okay? And also the d, which is this one. Okay? And simplifying, remember, F is equal to KD. Okay. Now, this one is this. Therefore, the remaining item here are the stiffness matrix. So, the whole stiffness matrix is phi inverse transpose double integral b transpose db dx dy times phi inverse. Okay. So B is zoom out natin. So therefore, this is the B matrix. Okay, and then the D is this one, B matrix. It's constant, no? Kasi given naman ang elasticity sa problem, the thickness of the plate, no, and the Poisson ratio, given yon. And the phi is this one, the phi matrix. And you will notice this is also constant because given ang dimension ng plate, A and B. Even dapat yan. Okay. So when you operate that in SMAT, this is what I did, which you have now also. So the B matrix is this one. Okay, so B matrix. Paki-check na lang din, baka may na-miss ako. Okay, ito yung chine-check ko din kanina before we start. No? So I hope wala akong na-miss. Negative 2x, negative 6y. Okay. Okay, next is, that's the B. And then the phi matrix. It's this one. So I designate that as, yeah, phi. Check na lang din. Yeah. It's the phi matrix. 1, okay, 0, 0, 1, 0, negative 1, 1, 0, B. Okay. So we have now the phi, we have now the B. The D matrix is this one. This is the D matrix. So when we combine them all, we have this. Yeah, I designate that as this one. So this is the K matrix. So I need the B transpose. So this is the B transpose. And this one, the D matrix is this. And B. Sorry, ginawa ko lang siyang transpose because basically yun yung B. This one. Ayoko lang i-retype ito ng ganyang kahaba. So that is the B matrix. Okay? So where's the phi inverse transpose? Where's the phi inverse? So REC, no? So I designate them all as RCEC. So the total K is this one. Yan. Okay. So I got the phi inverse transpose. Then this is the REC in SMAT. And then the phi inverse is this one. So I have my total K matrix per element, per plate element. Okay. So now you know how to use the code. No? So when you have a data like a problem like this, for example, a 10-inch by 10-inch square plate. So my A is 10, my B is 10. This is the elasticity, 30 times 10 raised to 6 PSI. Poisson ratio 0.3, thickness is 0.1. And then just press calculate. Then you will have this K, total K matrix. Okay. So I haven't, I'm still checking in STAAD. No? For example, I need to pa-check na lang din, no? For example, I modeled a 10-inch by 10-inch plate here. Then nag-subject ako ng load na happened. Where's my load? Loading. So this is a 25 pound, yung 0.11 kilonewton. Punta tayo sa geometry. 10-inch. 0.25 or 250. Tama. This is 10-inch by 10-inch. Then properties. Ano properties ito? This is 0.1 inch. So kaya 0.0025 meter or 2.5 mm. And my loading is 25 pound or 0.11 kilonewton. And then run analysis, you will have 10 mm displacement. Remember, I'm only using a, we call that, this is not exactly the plate in STAAD. I think STAAD uses a hybrid element. So as per their technical description. While in our problem, we are just using what? An extension, only an extension of Euler-Bernoulli or a thin plate element. We call thin plate element because we did not consider the shearing deformation. Unlike in STAAD, I believe it's only it's also considering the shearing deformation. Anyway, so the result is 10.8 mm. Maximum vertical deflection. While in my SMAT, of course, there's a discrepancy. I'm getting 0.29 each. So 0.29 is about 7.44 mm. So this is 7.44 mm compared to STAAD 10 mm. Okay, so there's a discrepancy. Okay, so that's it. So you have this SMAT na, no? I've already sent it to you. The reason na nag-send ako ng part 2 is because, for example, if mag-ano kayo, this one, the part 2, if imi-mesh nyo ng 4, let's say, remember this is only a single plate. Itong, itong stiffness matrix na yan. So sa part 2, if minodel nyo siya ng 2x2 or 4 plates, you will need 4 stiffness matrix, di ba? You will need 4 stiffness matrix. So meron ako ditong K1, K2. So basically, pwede nyo i-paste yung nakuha nyo sa part 1 here. Yan. Di ba? For example, minodel nyo siya ng 4x4 para mas finer, mas di ba? Mas accurate, no? So if you model nyo ng 4x4 yan, so you need 4 stiffness matrix, right? Tapos if yung load mo nandito, and you will define a force vector na corresponding to the degrees of freedom at that node, no? Kung saan naka-apply yung load, di ba? Yun lang po, no? So I need 4 stiffness matrix, then same concept, get the BU and BB matrix, and I still uses the same stiffness code. You may I suggest you check that. And this is my S matrix and then my corresponding displacement. Okay, yun lang. So that's it. So that's the last lecture, plate bending.